Hello, dear students. Here I want to express you some problems about concentration. In general, concentration of a solution is the amount of solute divided by the amount of solution. The solution in general is the sum of solute plus solvent. One of the ways we can express concentration is using molarity. Molarity is the number of moles of solute per liter of solution. Be careful with this. The volume of a solution will be always in liters, not milliliter. And the moles of the solute generally can be calculated from the mass of the solute divided by the molar mass that you can calculate from the periodic table. For example, for sodium chloride, the mass of 1 mole of sodium is 23, and the mass of 1 mole of chlorine is 35.5 grams per mole. Then the molar mass of sodium chloride is 23 plus 35.5, that is 58.5 grams per mole. And let's go to an example of how to solve a problem like this. Here we have a solution of sodium chloride that contains 5.845 grams of sodium chloride. The molar mass, as I told you before, is 58.45 grams per mole. You have to calculate this from the periodic table. The moles of sodium chloride in this case is 5.845 grams divided by 58.45 grams mole. You cancel out grams with grams, and the answer is 0.1000 moles. Why 1, 2, 3, 4 significant figures? Because the given number has 1, 2, 3, 4 significant figures. Now, the solution is 500 milliliters, but you cannot work with milliliters. You have to change this into liters divided by 1,000. And it is 0.5 liters. Why 0.5? Only one significant figure, because the given number has one significant figure. Then you divide moles by liter of solution, and you get 0.2 molar. Moles per liter is molar. And it's only one significant figure because one of the numbers in the calculation has one significant figure. And you take into account the lower, and the number with lower number of significant figures. Let's go to a general formula. If you use this diagram where moles is here, molarity is here, and liter is here, for example, if you want to calculate moles, what you do? You put your fingers over moles, and then you multiply. In this case, you have to multiply 18.5 molar per 2.00 liter, and then you get, you cancel out liter with the liter, and then when you multiply these two numbers, and you get 37.0 moles of sulfuric acid in this case. Let's continue to the following exercise. Well, in the following exercise, I'm going to give you the percent concentration. The percent concentration can be expressed in more mass of solute per mass of solution times 100, or mass of the solute per milliliter of solution times 100, or milliliter of solute divided by milliliters of solution times 100. One example is here. You have that neomycin is an antibiotic cream that contains 300 milligrams of neomycin sulfate, that is the active ingredient, in 30 grams of the ointment base. Then you divide mass of solute by mass of the solution, you multiply by 100, in this case is 0.3 grams of neomycin sulfate by 30 grams of solution, multiply by 100, and you get that it is 1%. Only one significant figure, because you have here one significant figure and one significant figure. Another example is this one. You want to express the percent concentration of paracetamol pediatric oral suspension that contains 3 grams of solute per 60 milliliter of solution. Then you divide 3 grams by 60 milliliters and you multiply by 100, and you get that the concentration of this paracetamol pediatric oral suspension is 5% mass per volume. If sometimes I give you the density and the volume of the solute, you can get the mass of the solute multiplying density by volume. You cancel out milliliter per milliliter and you get grams. This is the case that I asked you per concentration mass per volume, and I am giving you volume of solute. If you have the density of the solute, you multiply and you get mass of solute, and you do your calculations. Well, that's all for today. Don't hesitate to ask me at any time. See you soon.